In this video, we'll show how to find the partial fraction decomposition of a given rational function. So the first step is to make sure that the fraction is written in proper form. That is, the degree in the numerator is less than degree in the denominator. This is not the case. That means to write it in proper form, I'm going to divide x squared plus x minus 6 into x squared, and it goes one time. So x squared plus x minus 6, subtracting it, so we have negative x plus 6 is the remainder. So my original function is actually 1 plus negative x plus 6 over x squared plus x minus 6. So I just have to I just have to decompose negative x plus 6 over x squared plus x minus 6. Now to decompose this fraction, we have to factor out the denominator, and if possible, reduce this fraction and make it look simpler. So factoring out the denominator gives us the following. So we notice how there is no common factors between the numerator and the denominator, so we cannot reduce this, but we can now start decomposing the function. So going through all the factors in the denominator, I'm going to write the following decomposition. So since x plus 3 has multiplicity 1, that means decomposition will have a fraction with denominator x plus 3 and some constant in the numerator. Going to the next factor, x minus 2, it's the same story. X minus 2 has multiplicity 1, so that means decomposition will have only one fraction with denominator x minus 2 and some number in the numerator. So this is what the general form of the decomposition is. Now we just have to find a and b. So to find a and b, what we're going to do is we're going to add these two expressions and write it as a single fraction. So to find the common denominator, we just multiply the two denominators since they have nothing in common, and now we multiply a over x plus 3 by x minus 2 in the numerator and the denominator, and we multiply b over x minus 2 by x plus 3 in the numerator and the denominator. Now what we want is, we want right hand side of this equation to always be equal the left hand side of this equation. Since the denominators already match, we don't have to worry about them, but we have to make sure that the numerators also match. That means negative x plus 6 is equal to a times x minus 2 plus b times x plus 3. Now there are two different ways to figure out the coefficients from here. In one of them we don't need to distribute a and b, and that method is called strategic substitution. However, in the other method, we do want to distribute a and b over, and not only we want to distribute them, we also want to combine the like terms in that polynomial. And this method is called equating coefficients. So first let's do this problem by equating the coefficients, as it is the easiest one to understand. Now we want these two polynomials to be the same all the time. That means we want a plus b as the coefficient of x on the right side to be equal to negative 1 as the coefficient of x on the left hand side. So we want a plus b to be equal negative 1. Also we want negative 2a plus 3b equal to 6, as both of them are the free coefficients. And now, as a result, we have a system of equations. which we should be able to solve by either substitution or elimination. So I'm gonna choose elimination. We can multiply the first equation by 2, so 2a plus 2b equals -2, and by adding these two equations we can solve for b. B is equal to 4/5. Similarly, we can multiply the top equation by -3b, and by adding these two equations we can solve for a. So we actually multiply by -3 to make it -3b, and we have -5a equals 9, so a is equal to -9/5. So we found the values of a and b, meaning we found the decomposition. So decomposition is -9/5 of x plus 3 plus 4/5 of x minus 2. Now let me show you how to find the same answer using the strategic substitution. The idea of strategic substitution is that we want this expression to be true for all values of x. So we want this to be true for x equals 0, for x equals 1, x equals 2, and so on and so on. So if we want this expression to be equal for x equals 2, then the following must be true. -2 plus 6 is 4. Now 2 minus 2 is 0, so 8 times 0 is 0, and 2 plus 3 is 5. So when x equals 2, we end up with the following equation, which is very easy to solve for b. b is just 4/5. Now another value of x that we can strategically substitute into this equation is -3. -3 with the negative in front plus 6 is 9, and -3 minus 2 is -5, and -3 plus 3 is 0. So we ended up with the following equation, which is easy to solve for a. A is just -9/5. So of course we ended up with the same exact values for a and b. So no matter which method you use, you'll have exactly the same solution. Now quick note about the strategic substitution. It works the best when all factors in the denominator are linear. So in this case we did have that, but in general it may not be the best approach.